Vladek is proposing a puzzle for this week, and we also, in the meantime, have a large amount of chocolate to distribute, courtesy of Allison's.
Okay, so the puzzle for next week is about elections. But it's not about real elections, it's kind of simulated elections, okay? Because by the time we were preparing this puzzle, election poll field narrowed down, so we don't have that problem in real life anymore. But theoretically, hypothetically, we may encounter that. So the problem is this. We need to select a winner based on voter preference. So different voters may have different preference profiles. For example, one voter may say, I prefer candidate A, candidate B is slightly worse, candidate C is the worst. Another voter may say, I prefer A, C is a little bit worse, and D is the worst to me. If B is elected, I'll go to Canada. That's the used to say, okay. And so, this is, if we only have two candidates, and we assume for simplicity, just for simplicity, there are no ties. If there are only two candidates, then it's very natural to select. You select the candidates for which the majority prefers A to B. Again, we're assuming that there's no tie. If 51% of the people prefer A to B, then A is elected. If 51% prefers B to A, then B is elected. If we have three candidates, then we have a problem, because what we can do many things. One thing we can do is select a couple of candidates and have a beauty contest between them. If majority selects A, B is dismissed. Then we compare, we select another pair, and we repeat this procedure until there is only one candidate left. So what we want you to do is give an example of preference profiles where this seemingly natural scheme has a flaw. And the flaw is, depending on in what order we compare them, we get two different winners. Okay?
So what we're looking for is a scenario where if you manipulate the order, you get a different winner.
Right. First start with comparing A and B. A wins. You start with comparing B and C. B wins, and so on. Okay? Ties is dismissed.
We're not going to have any ties.
There are no ties. Right. Ties make the problem a little bit more complicated, so we're just doing it the fair basics. No ties.
Since it's election year, we thought it would be fun to have an election problem. So,
actually, some people in 1951, I'm giving you a hint, one person got a Nobel Prize for proposing this counterexample.
Yes,
well, not exactly this, but slightly more difficult.